Hello everyone. We have two questions here. How many three-digit numbers are divisible by 7? And how many multiples of 4 lie between 10 and 250? Now, as these two questions are somewhat similar, let me do one for you, and on understanding that, I think you will be able to do the other one on your own. Now, the first question first, how many three-digit numbers are divisible by 7? Now, what are the three-digit numbers? They start from 100 and the three-digit numbers go on till 999. Now, we will have to find the first three-digit number which is divisible by 7. In order to do that, let us just try dividing 100 by 7 and see what our remainder is. 7 ones are 730, 7 fours 28. So the remainder we get is 2. So the conclusion we arrive from here is 100 minus 2, 98 would be the last two-digit number which is divisible by 7. So 98 plus 7, 105. 105 would be the first three-digit number which is divisible by 7. And now we know add 7 to 105 and we have a number of terms, all three-digit numbers which are divisible by 7. Now in order to find the last number which is divisible by 7, we'll just have to repeat a similar process. Just divide 999 by 7 and check what your remainder is. 7 1 7, 29, 7 4s 28, 19, 7 2s 14. So now we have a remainder 5. So if 5 is the remainder, the conclusion is if you subtract 5 from 999, you arrive at a number which is divisible by 7. So the number is 994. 5 is the remainder, so it should, if it had been 14, there wouldn't have been any remainder. So this 5 is excess. Just subtract the 5 from 999, you get 994. Now this is going to be our last three-digit number which is divisible by 7. Now what is our question? How many three-digit numbers? So how many terms in this arithmetic progression? This is of course an arithmetic progression because the common difference is going to be 7 and the first term is 105. So just let us find the value of n, the number of terms in this arithmetic progression, and we would have solved the question. So how many terms? In order to do that, we know, or we'll just follow that pattern. A plus n minus 1d is equal to the last term, 994. Why have we arrived at this? Because this is your first term which can be written as just a. The next one would be a plus d. The next term would be a plus 2d and so on. So this is of course a plus 0d. So this, the last term, can be represented as a plus n minus 1d, right? And this is equal to 994. Just substitute the values you know here. 105 plus n minus 1 into 7 is equal to 994. So what do we have? 7 into n minus 1 is equal to 994 minus 105. What is 994 minus 105? 14 minus 5, 9. 8 minus 0, 8. And 9 minus 1, it is 8. So 889. So now let us divide both sides of the equation by 7. We get 889 by 7, which is 7 ones are 7. 7 twos are 14, 49, 7 sevens are 49. So n minus 1 is equal to 127. So n is equal to 127 plus 1, 128. So the conclusion is there are 128 numbers. There are 128 numbers, three-digit numbers. 128 three-digit numbers which are divisible by 7. See, using arithmetic progression, we have determined this so easily. isn't it? Now, what about the second sum? The second sum is, I'm sorry, how many multiples of 4 lie between 10 and 250? So it is almost very, very similar to this. You just have to find the first number after 10 which is divisible by 4, which is 12, because it's a small number. We know it is 12. And what about 250? What is the nearest number lesser than 250 which is divisible by 4? You can just follow the same procedure and find the remainder. 4 6 are 24, 10, 4 2s are 8. Since 2 is the remainder, I think the largest number, which is the less than 250, which is divisible by 4, would be 248. Now, for this arithmetic progression, which has a common difference as 4, because they are multiples of 4, and whose first term is 12, you can follow the same pattern. The last term is represented by a plus n minus 1d. So, writing it, equating it to a plus n minus 1d, we can arrive at the value of n. Let me do it quickly. I think you can pause the video and you can do it on your own also. So, a is 12 plus n minus 1 into 4 is 248, or 4 into n minus 1. You're just subtracting 12 from both sides. You get 248 minus 12 is 6, 4 minus 1, 3, 236. So, n minus 1 is equal to, dividing both sides by 4, we get 4 5s 20, 4 9s 36. So, our n, the number of terms or the number of multiples of 4 between 10 and 250, which lie between 10 and 250, are 60. There are 60 numbers which are multiples of 4 between 10 and 250. I hope this problem is very clear to you. Thank you.